Okay, so this is chapter 3, integration. So integration is actually the inverse of differentiation, as you can see here. Inverse of differentiation. So if you remember differentiation, then integration works in the opposite way. So let's see A. Based on the given differentiation, determine the integration of each function. Okay, so before we look at this example, let's look at the notes here first. In differentiation, we differentiate the fx, then we will get f prime of x. Let's say one example. If I differentiate 5x squared, 5x cubed, let's say, then differentiation is where the power 3 move in front, multiply with 5, then you get 15. Then the power decrease by 1 unit becomes square, 15x squared. Okay, now in integration, let's take a look. In integration, it is the other way around. You integrate the f prime of x. That means you integrate this one. You integrate this, 15x squared. The symbol of integration is like this. We have this symbol like a snake, followed by dx. What you want to integrate, you put in the middle. So that means if you integrate 15x squared, then you will get fx. You get fx. So which means this one. This is your fx. This is your f prime of x. So based on the formula, if you integrate f prime of x, then you will get fx. Okay, you will get fx. So what is our fx? 5x cubed. So you will get 5x cubed. So that is what I mean by inverse of differentiation. So differentiation, 5x cubed differentiate 15x squared. When you integrate, then you will get back the 5x cubed. Okay, so let's say one more example. Okay, this is example 1. Now let's say example 2. I purposely put it in the similar way. 5x cubed plus 7. So when you do differentiation, what happens is you will get 15x squared. The differentiation of 7 will end up with 0. Okay, so that means now when you integrate 15x squared, then you will get this thing. When you do integration of the f prime of x, then you will get back your fx, which is 5x cubed plus 7. 5x cubed plus 7. Okay, now let's see number 3. One more example. If I do 5x cubed minus, let's say minus 4, if I differentiate it, again I will get 15x squared. 15x squared. Then minus 4, when you differentiate, you will get 0. So minus 4 disappear. So because of that, when you integrate 15x squared dx, where you're supposed to go backward, from 15x squared you go backward and come back to this, and then you will get 5x cubed minus 4. Okay, you get this. So you may observe something. You may observe something like this. I integrate the 15x squared, 15x squared, and 15x squared. How come this round I get 5x cubed, and the second round I get 5x cubed plus 7, and the third round I get 5x cubed minus 4? I am integrating the same questions, but how come it come up with different answer? Different answer, 3 different answer. So of course, this is the problem. And in general, we just put all these in this way. When you integrate 15x squared, we will just write it as 5x cubed plus c. 5x cubed plus c. The c is any number lah, okay? So it can be -4, it can be 7, it can be 0 for this case, okay? So in general, we put it in this way, 5x cubed plus c. So you can always see plus c over there because the c is not fixed, can be any numbers, okay? Let's see example over here. Okay, so in this example, what happened is, given that the differentiation of x minus 7 to the power of 5, so you know we use chain rule where the power 5 bring in front, so that's why the 5 is here. Then x minus 7 to the power of 4, then we're supposed to have one more thing. We differentiate the thing in the bracket. Differentiate x, you get 1. Differentiate minus 7, you get 0. So that's why you're supposed to have 1 at the back. But multiply with 1 is just nothing. Okay, so we write back the same answer in this way. So what happened is, this is chain rule. You differentiate this, then you get this. And we have to know that this is your fx. After differentiation, this is the f prime of x. So of course you can refer to notes at the same time. So before you differentiate, we call it fx. After you differentiate, you call it f prime of x. Okay, now integrate 5x minus 7 to the power of 4. Integrate f prime of x. So based on our formula, when you integrate f prime of x, you will get fx. You will get fx. Okay, so you will get fx. Okay, so we write like this: integrate 5x minus 7 to the power of 4, and then you will get back the fx. The fx is x minus 7 to the power of 5. So like this. Okay, now let's come back to our situation over here. Okay, our situation over here. So just now I put 4 situations. This one, and then this one, and this one. 4 situations. 5x cubed, 5x cubed plus 7, 5x cubed minus 4, and 5x cubed plus c. So which one to follow? The idea is like this: if you have fx given, then you put fx, like this also. Fx is given, then you put fx. Fx is given, then you put your fx. Okay, but if you don't know your fx, let's say for example, fx is not given, then you just put this plus c. So when fx is not given, you put plus c. When fx is given, you don't put plus c, just put your fx. Okay, so we will see more example. Now you remember it first. I write down: if fx is given, then integrate f prime of x dx equal to fx, and plus c is not necessary. Okay, so if fx is not given, use plus c. Okay, so you take it in this way first. Let's see more example. Okay, now question 1, 2, 3 I will let you try afterwards. Let's see B. Okay, part B. Given that y equal to 4x cubed, find dy dx. Find dy dx. So we do differentiation. Okay, so this is the previous chapter. 4x cubed dy over dx equal to 12x squared. So this is the fx. After differentiation, this is the f prime of x. Okay, now let's see next part. Hence find integration of 12x squared dx by using the reverse steps to dy dx. Okay, so they ask you to integrate this by using the inverse of differentiation. Okay, 12x squared. Okay, 12x squared is what? 12x squared is f prime of x. It's f prime of x. When you integrate, you will get your fx, which is 4x cubed. 4x cubed. 4x cubed. Do we need plus c or not? No need, because fx is given. Fx is given as 4x cubed. So no need to put plus c. So not necessary. Okay, now let's see the next page. Okay, on this page we have indefinite integral. Indefinite integral is where we do integration on its own and without using the inverse of differentiation just now. And the thing is, when we don't know the fx, our situation now is we don't know the fx, so we have to put plus c. Okay? And now we have to use formula to integrate. So you see the formula. The first formula, integrate k equal to kx plus c. Integrate k equal to kx plus c. So k is a constant. Okay, it's a constant. So you integrate any constants, you will get constant x plus c. Okay, now example. If I integrate 3, I will get 3x plus c. If I integrate half, I will get half x plus c. So something like that. Okay, that's the first formula. Of course, you may think of differentiation that we learned last time. Actually, it's just the other way around. If you differentiate, for example, if you differentiate 3x plus any number, 3x plus 4, your dy dx is 3. If you still remember that, 3x become 3, then 4 after differentiation become 0, so you get 3. And integration is just the other way around, no? Integrate 3, then you get 3x plus c. I put c because we don't know the fx, this is my example. Okay, but in actual situations that don't give fx, then you have to put plus c. So let's see the next formula. Integrate x to the power of n dx equal to x to the power of n plus 1 divided by n plus 1. Okay, so example, integrate x to the power of 2. When you see this formula, right, you try to take it in this way. First, plus 1 to the power, then divide by the power. The power is, the new power is n plus 1, so you divide by n plus 1. Okay, so the concept involves plus and divide. Plus and divide. Not like differentiation. Differentiation, let's take a quick look. Differentiation, if you have y equal to x to the power of n, right? So dy dx is nx to the power of n minus 1. You can see what happened is we bring the power in front, we multiply, and then we minus 1 to the power. So it involves multiply and minus. But this integration, which is the inverse, it involves plus and divide. Okay, so it's like opposite. Okay, let's see one example. Integrate x squared become x squared plus 1 over 2 plus 1. Of course, 2 plus 1, let's count straight away. X cubed. 2 plus 1 at the bottom means 3. Plus c. So we can take it in that way. So integrate. If let's say you have 1 over x squared. 1 over x squared. Then you have to bring up the x squared. You bring up the x squared, it becomes x to the power of minus 2. But bear in mind, we still need to write this integral sign. So that means you still need to write this and this. You still need to write this too, because we haven't started integration. Integration means you have to do something like this. We haven't do that. We just rearrange the questions so that we can use this formula. And now we can use the formula already. Then we are going to plus 1 to the power, and no need to write this and this anymore. Okay, so let's see. X minus 2 plus 1. Okay, minus 1 straight away. Minus 2 plus 1 is minus 1 over minus 1 plus c. You will see that I don't write the integral sign anymore, the snake shaped, this one. I don't write this anymore. The dx at the back I don't write also, after I use the formula. So I get something like this. It doesn't look nice if you leave this as the final answer. So I simplified it. I know when x take negative power, you can bring it down. So negative 1 over x plus c. Negative because of this. This one I bring in front. The x go down because x take negative power, so it goes down. So we get something like this as the final answer. Okay. One thing that you need to know here is this second formula, right, is not applicable if n is minus 1. Cannot be minus 1. Imagine that if n is minus 1, right? Minus 1 plus 1 at the denominator, we end up with 0. Something divided by 0 is undefined. So not applicable when n is equal to minus 1. We have other formula, but we will learn later. Okay, we will learn later, not in SPM. Okay, so we will learn a formula on how to handle it when n is minus 1. So will be the mathematics after SPM. Okay, so let's look at the next one. The next one, similar to the second one. Integrate ax to the power of n. Ax to the power of n. Then you will get ax to the power of n plus 1 over n plus 1 plus c. So the idea is plus 1 to the power divided by n plus 1. Divide by the new power. Okay, so let's say example. If I have 4x squared, integrate 4x power 3. So you can see I plus 1 to the power 2, and then I divide by 3, then plus c. Okay, so 4x cubed over 3 plus c. So like that. Okay, and then another example, let's say if I have 4 over x squared, and then what should we do? bring up the x squared and it becomes 4x minus 2. You see I'm still writing the integral sign because I haven't started integrating. Now it is ready, I can start integrating. 4x minus 1 over minus 1 plus c, simplify, minus 4 over x plus c. Okay. One more example. If I have 4 over 3x5. Okay. So when you want to bring up the x, right, with the power, you don't bring the number in front. The number in front, you remain it as 4 over 3, like this. So only the x come up and it takes negative power. And then you integrate 4 over 3 x minus 4 over minus 4 plus c. Okay, then you cut the 4 here and here, then you will get negative 3 at the bottom. So negative 1 over 3x4 plus c. Okay, so that's the thing. And let's look at one last example. I try to relate with this. Okay, look at this. If I integrate 3, it is actually 3x power 0. 3x power 0. You know, x power 0 is 1. So integrate 3 is same with 3x power 0. Okay, so I purposely put it in this way so that you can understand it by using this formula. Okay, so if I'm using this formula to integrate this, so integrate 3 become 3x power 0. Now, based on the formula, 3x power 1 over 1 plus c, 3x plus c. So you can see 3x plus c, same as this one, 3x plus c. So now let's see example. First one, A, integrate 6. So integrate 6 based on the first formula, 6x plus c. Okay, B, integrate 14x cubed. So based on the third formula, because you have A, the A is 14. So based on the third formula, it becomes 14x power 4 over 4 plus c. 14 over 4 is 7 over 2. Okay, now question C. Question C, 7 over x to the power of 6. So we need to bring up the power 6 first before we use the formula. So we will get 7x to the power of negative 6. And then we integrate, and the integral sign no need to write anymore from this point onward. 7x minus 5 over minus 5 plus c. So minus 7 over 5 x5 plus c. Okay, so these are the three examples on how we use the three formula there. And let's see part B. So part B is where we need to expand first. 2x you expand with x, 2x you expand with 5, then you integrate term by term. We can do so if the terms are like adding or minus with each other. Okay, so we expand first. 2x squared plus 10x. So you see I expand it and I'm still writing the integral sign. Okay, the integral sign come in one set. This is the front part, this is the back one. So they come in one set. So this and this must be there at the same time. Then the question is in the middle. Okay, now we can integrate term by term. 2x squared. it becomes 2x cubed over 3. 10x is like 10x to the power of 1, so it becomes 10x squared over 2 plus c. Okay, then I write here equal to 2x cubed over 3 plus 5x squared plus c as the simplest answer. Okay, so from here we understand that if you can expand, you expand first. You expand, then only you integrate afterwards. Okay, so expand and integrate. Now let's look at the next page, a bit more example. Okay, so let's see how we handle it if you have this situation. Just now I say if you can multiply, you can expand, you have to expand first. Now if you have a division here, the idea will be the same. If we can divide first. Okay, so of course it's one terms at the bottom, then we can divide. If it's two terms at the bottom, then we cannot divide anymore. Like for example, if you have 3x squared minus 5 divided by x plus 1, then we can't divide anymore. We have to use other way. Okay, so where we are not going to care about this actually. But if you have one terms only, you can divide. So how we divide? Every terms on top divide by x to the power of 5. So 6x power 7 over x5, 2x squared over x5, 7 over x5. So we can do this. Remember that we can do like this if the denominator has only one term. And then you can take each term on top, divide by the only term at the bottom. Okay, I simplify first. The integral sign we still need to write. We just simplify the question. We haven't started integrating. Integrating is like you add 1 to the power and so on. So we haven't do those things yet. So I just simplified it to 6x squared. This one 2 minus 5 is negative 3. This one you bring up the x power 5 is 7x to the power of minus 5. Okay, now the three terms there are getting ready for integration. So we integrate 6x cubed over 3, 2x minus 3 minus 3 plus 1 minus 2, 7x minus 4 plus c, and then we continue. So now what we need to do is we simplify. Okay, we simplify it to 2x cubed plus, cut away the 2, minus become plus, x minus 2 I can bring down 1 over x squared, and then minus 7 over 4, x minus 4 I bring it down, x to the power of 4 at the bottom, plus c. Okay, so like that. Okay, let's see one more. Okay, one more, part C. Okay, part C is the opposite of chain rule. Let's look at the formula first. Last time when you learned chain rule, right, y equal to ax plus b to the power of n. Differentiation is this power bring in front, n, then ax plus b, then n minus 1. Then you still need to differentiate the ax plus b. You will get a. Okay, so differentiation is like that. Integration is just the other way around. You need to plus 1, then you need to divide. So you see, integrate ax plus b to the power of n. So you plus 1 to the power. Then you have to divide by the new power, n plus 1. You still need to divide by a. So the a comes from where? The a comes from the differentiation of ax plus b. You differentiate ax plus b, you get a, so you divide by a. Then plus c. Okay, so let's see example. We use this formula when you have a linear form with power n. Like this, linear form. Linear form means the x takes power 1. So something like this, take the x is power 1 here, no? So this is linear form, and this whole linear form takes a power. Then we can use this formula. Okay, so basically the 6 over there, you don't need to care one. 6 5x minus 2 power 4 over 4, and the a is, imagine you differentiate 5x minus 2. You differentiate 5x minus 2, you will get 5. So we divide by 5. And then 6 over 20 is 3 over 10. Yeah, so this is how we handle it. Okay, so if you are wondering why we are not going to care about the 6 here, so as long as the constant is multiplying with the question, this constant you can just leave it there, no need to do anything. But if the constant is plus or minus with another one, then you need to integrate it. If it is plus or minus, something like the previous questions. Okay, like let's say for example, okay, maybe I just write here, easier for you to understand on what am I talking about. So if the constant is plus 6 plus 5x minus 2 cubed dx, and then we need to integrate this one, we need to integrate. But if they are multiplying, no need to integrate the 6. This one plus or minus, then you need to integrate the 6. Integrate 6 become 6x. Then integrate the 5x minus 2 power 3, it become 5x minus 2 power 4. Divide by 4, and also divide by the a, and the a is 5 plus c. 6x plus 5x minus 2 to the power of 4 over 20 plus c. So you try to see the situation here. Okay, when the 6 is multiplying, no need to care about it, no need to integrate it, just leave it there. But if the 6 is plus or minus with the thing, then you need to integrate the 6, then you need to integrate this also. Okay, so that's the difference. Okay, now let's look at b. This is not ready yet because it's at the bottom, so I bring it up. Bringing it up doesn't mean it is integration. So because of that, I need to continue to write the integral sign. And you will realize when I bring up the whole bracket, from positive 3, it's now negative 3. Okay, now I can integrate by using this formula. So this 4 is multiplying, no need to care about that, just leave it there. 4 6x minus 1. Okay, so this power is minus 3, so you have to plus 1 to it. It becomes minus 2. Divide by minus 2, divide by a plus c. Okay, then lack of space. 4 over negative 12 is 1 over negative 3. 1 over negative 3, so I write it down here. 1 over negative 3. I put the negative in front. At the same time, I bring down the bracket with negative power. So if it says negative power, you bring it down. It will become positive power. 6x minus 1 power 2 plus c. Okay, so like that.